Hi, welcome to the Olympiad Geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So, I have an update for the problem of the day for a long time. Let's just look at the problem of the day 15. This is a problem from USA Math Olympiad in 1996. So it seems that the triangle ABC has the following properties: that existing a point P so that angle PAB equals to 10 degrees. So let's just draw AB here first. Okay. Let me make it larger. So AB here. So we know that angle PAB equals to 10 degrees. It's pretty small angle, right? And angle PBA equals to 20 degrees. So look like this. This is 10 degrees. This is 20 degrees. Okay. And angle PCA equals to 30 degrees. Angle PAC equals to 40 degrees. So here is P. We know that angle PAC is 40 degrees. And we know that angle PCA is 30 degrees. So this point is C, and we connect CB, right? I think this problem I solved before, but anyways, let's just do it again here. So this is 40 degrees, this is 30 degrees. Prove that triangle ABC is an isosceles triangle. So basically, it's asking us to calculate for the angle PBC and angle PCB, right? Once we know all the angles of the triangle ABC, we can easily prove it's an isosceles triangle. So the question is that how can we, of course we need the auxiliary lines, right? But the question is how can we add the auxiliary line? For this problem, we notice that 10 plus 20 equals to 30, 30 plus 10 equals to 40, or 10 plus 10 equals to 20. So we have to use these like angle added up relationship to find the breakpoint, right? So here we know that angle PAC is 40 degrees. If I split it into 30 degrees plus 10 degrees, then we can get an isosceles triangle first here, right? Right, so I split the angle PAC to 30 degrees and to another 10 degrees. Right, let's call this point as D. Now we know this edge equals to this edge, right? DC equals to DA. And if we connect DB and also extend BP, right, intersect AD on point E. So we know that the angle APC equals to 180 degrees minus 30 degrees minus 40 degrees, which is 110, right? That's the angle APC, this angle. And for the angle APB, it equals to 180 degrees minus 10 minus 20 equals to 150 degrees, right? So this is 110, this is 150, which means angle BPC equals to 360 minus 110 minus 150 equals to 100, right? So which equals to 90 degrees plus 10 degrees equals to 90 degrees plus half of angle BAD, right? That means point P. See, AP is an angle bisector, and angle BPD equals to 90 degrees plus half of angle BAD, which means point P is in center of triangle ABD, right? Based on that, we know that angle PBD equals to 20 degrees, right? Equals to angle PBA. Angle PBD, this one, equals to this one. So this is another 20 degrees. Now, if we think about the angle ADB, it equals to the angle ADB equals to 180 degrees minus 2 times 10 degrees minus 2 times 20 degrees, which is 120 degrees, right? That's the angle ADB. And angle ADC is 120 degrees because this is 30 degrees, this is 30 degrees. So total is 60 degrees, 180 minus 60, that's 120 here for the angle ADC. Right? So we know that angle BDC equals to 360 minus 120 minus 120, that's 120 degrees. Okay, now we can see, we know AD equals to DC. And we know DB equals to DB. And also angle ADB equals to angle CDB equals to 120 degrees. Which means triangle ADB is congruent to triangle CDB, right? Which means angle DBC equals to angle DBA equals to 40 degrees, right? So this is 40 degrees, and this one is 120 degrees. So we know here is 20 degrees, right? That make angle BAC equals to angle BCA equals to 50 degrees. Therefore, CB equals to AB, and triangle ABC is an isosceles triangle. Okay, so this problem, I would say this is a difficult problem for the people don't know about the in-center property, right? But if you know the in-center property, and you figure out that this might be the auxiliary line because it can provide us an angle bisector, also can provide us an isosceles triangle. So this problem would be kind of straightforward then. Okay. So let's say for the problem of the RMO, usually it requires you to have like more than 2 or 3 breakpoints, right? But for these states level computation, I usually only have 1 breakpoint. So if you can get it, then the problem is done. Okay, I hope you like this one. See you in next video. Thank you.